growing. It's great, dear Bekir Aksoy. Ben arada yine İngilizce olarak da şey yapayım mı hocam? Arkadaşlar ayıp olmasın.
Tabii ki.
Sıkıntı yok yani katılım bayağı fazla iyi. Yani.
İyi hocam inşallah. Bu ilk katılım böyle güzelse bundan sonrası inşallah daha da güzel olur Utku hocam.
Aynen hocam. Aynen.
Şu an 90 participant gözüküyor.
Değil mi? Yayın süreçlerini ben yine sorarım bakalım. Yaparız. Hani bir günlük bir etkinlik ama yayın tarafına bakarız yani ben bir sorarım.
Tamam hocam sıkıntı değil. Yaparız inşallah.
Aynen.
Hocam ilk konuşmacı ben kaçıncı sırada konuşmayı yapacağım hocam? Bir bilgi var mı?
İlk de olabilir hocam, ikinci de olabilir.
Nasıl dersin hocam? Siz nasıl uygun
İkinci
görüyorsunuz?
herhalde.
Tamam hiç problem.
Sizden sonra ben. Tamam.
Olur hocam hiç sıkıntı değil hocam.
Yani Isparta Applied Science University olarak siz de sonra STU yani Suleyman Demirel tarafı ben de. Sonra ben bir de Keynote speech var. Onunla devam ederim. Ondan sonra bir Keynote speech sonra bitiyor galiba. Yani
tamam hocam. Tamam Sayın hocam.
Tamam. YouTube şeyi de varmış. Onu da paylaşalım olmazsa.
Olur hocam.
YouTube.
Welcome, Professor Gupta from College of Engineering, Roorkee. How are you, sir?
Thank you. Thank you so much. Thank you so much. Bye-bye.
Thank you. Apurva?
Yeah, I'm good. Very nice.
Yeah, thank you. Apurva, beta, you can start now.
Yes, sir. Good afternoon, ladies and gentlemen. I'm Apurva and I'm the host for today's inauguration program. On the behalf of organizing committee, I welcome you all to the first international conference on computational research and data analytics, ICCRDA 2020. The conference is jointly organized by Indo-Turkey universities, that is Suleyman Demirel University, Turkey, Isparta Applied Sciences University, Turkey, and College of Engineering, Roorkee, India. And the conference is organized in association with ICCRLAB and supported by Universal Innovators, New Delhi, India. ICCRDA 2020 is organized with the objective of bringing together innovative scientists, professors, research scholars, students, and industrial experts in the field of sciences, computational methods, and techniques to a common platform. The primary goal of the conference is to promote the exchange of innovative scientific information between researchers, developers, engineers, students, and practitioners. Overall, the conference will provide the researchers and attendees with the prospect for national and international collaboration and networking among universities and institutions from India and abroad for promoting research. As we know, conference themes surround on computational research and data analytics, which is emerging field in 21st century. The main purpose of research is to inform action, to prove a theory, and contribute to developing knowledge in a field or study. During the last decades across all fields on engineering sciences, the evolution of complex system in design and manufacturing system processes has progressed along with the development of computational methods that can treat more and more complex design and simulation problems. Data analytics plays important role in the process of examining data sets to draw conclusions about the information researchers have. To begin our session, I would like to invite Professor Dr. Utku Kos from Suleyman Demirel University to address everyone with his precious views.
Thank you very much, dear Apurva. Welcome everybody to our first international conference on computational research and data analytics. We are very grateful to see many of the participants from around the world, as jointly organized by Suleyman Demirel University and the Sparta Applied Science University from Turkey, and also College of Engineering Roorkee from India. We just have realized such a great event with many of the knowledge and knowledge sharing and the most of the information regarding the most recent and cutting edge research regarding especially computational intelligence and the related data analytics efforts. As you know, we are just experiencing that the issue of the COVID-19. So because of that, we just transferred the sessions to the online mode. But we hope that the next time the event will be in the face-to-face mode at least, and we will be all each other meeting face-to-face. I'd like to also thank dear colleagues from India, my friends and dear brothers, dear Dr. Deepak Gupta and also Dr. Ashish Khanna, and all professors, respective professors from India, having great efforts to realize that event. And also, as you know, that the COVID-19 has appeared many things in terms of new normals. We were just talking some about with my colleagues just before starting to the welcome ceremony, that the COVID-19 has changed many things around the world. It has changed the lifestyle. It has changed the meaning of the information, because we need the massive data to make everything understandable in terms of the real world solutions. And in terms of fighting the COVID-19, we try to provide many different developments, and we try to catch the time because the data is flowing and the time is going. So we should be having the great the support by the technological developments in terms of, for example, computer and information technology. So combining all of them under the informatics, we just reached to the many different advanced technologies like artificial intelligence or other smart tools, as we know, the IoT or other things, the wireless communication networks, and also many other things in terms of all information processing and ensuring communication are very important for now. And the medical is very important, as you can see, and we just should be trying to shape the future of the humankind with the better and the positive outcomes from the technology side, not having the disadvantages of technology, but the more giving the support for the rise of the better positive outcomes. So such events are very important in terms of informing the audience around the world about the recent research works. So that event have many great sessions combining all of things regarding the computational solutions and also data analytics. We need the data analytics, we need the meaning, giving the meaning to the information flowing around the computational systems. So that event is another great step for rising the knowledge and sharing everything around the world with the world in order to make great collaborations for the future. As you can see from the program, we have many different sessions combining the machine learning, deep learning, image processing, and many other things regarding especially not only computer but also hardware-oriented solutions. So I'd like to welcome everybody, all dear valuable professors, colleagues, and students from around the world to our great sessions. I hope you have enjoyed all the sessions till so far in the morning. And we have great keynote speeches also. One of them is mine, of course. So I'd like to thank everybody again, and my dear friend also from the Sparta Applied Science University will give more information about the sessions, of course. So thank you very much. Let's hope all the best and stay safe and healthy. Thank you.
Thank you, sir. Hope we will meet in face-on-face next time. Now, I would like to invite Assistant Professor Dr. Bekar Aksay from Isparta Applied Sciences University, Turkey.
Mikrofon kapalı hocam. Microphone is muted, dear friend. Yes.
Excuse me. Thank you so much, Mrs. Apurva, dear colleagues, respectable professors, valuable students, and participants from all over the world. Welcome to the first international conference on computational research and data analytics due to the emergency study caused by coronavirus. We are currently organizing that event the online mode. But of course, we are all here to share the most recent knowledge as well as advances in the computational research and data analytics. Science is unstoppable. Research efforts are unstoppable. In even the most critical issues affecting in the world and the life, science finds the most sophisticated ways to take the humankind a safer place. Acknowledging that, we are running that international event by creating a valuable collaboration between three institutions: Suleyman Demirel University from Turkey, Sparta Applied Science University from Turkey, and College of Engineering Roorkee from India. As the Sparta Science University from Turkey, we are believe practical methods and solutions for a better world. In the context for this aim, the first international conference on computational research and data analytics combined 9 sessions focused on machine learning, deep learning, intelligent optimization, data mining, networks, image processing, and recent advances in Internet of Things. We are also hosting valuable keynote speech session for you, a valuable audience. Our event also comes with agreed publishing opportunities to improve visibility of high-level research force present in the sessions. I would like thank to also Intelligent Communication and Computational Research Lab for associating that international event. Without their great efforts, the event would not have been realized. As promoting international research and project activities, Intelligent Communications and Computational Research Lab is among key bodies to rise the technology level more and more for the better future. At the time of the coronavirus era, everything has changed and the technology has shown its importance in terms of knowledge creating, sharing, and communication to use knowledge for technological advances. By leaving that, I would like to thank you everybody here and send all respects to the participants for joining in such a great event. I wish also that I will be face-to-face soon to run such great events. Thank you for joining. You are welcome ceremony, and I wish full health and enjoyable life ahead of a lot of us. Thank you so much.
Thank you, Becker Aksai. Thank you, Professor Becker Aksai, for such wonderful speech. Now, I welcome Professor Dr. S.P. Gupta, Director General of COER Roorkee, Professor Dr. B.M. Singh, Director of COER Roorkee, and Dr. Adesh Kumar Arya, Associate Professor of COER Roorkee in this inauguration program. I would like to invite Professor Dr. S.P. Gupta, Director General of COER Roorkee, to share his views. Sir, I hand over virtual room.
Thank you so much, Apurva. A very good afternoon to everyone, dignitaries and delegates. I, on behalf of College of Engineering Roorkee, wish to thank the organizers and Professor Utku Pose, Professor Bekin Aksoy, Dr. Ashish Khanna, Dr. Deepak Gupta, and Mr. Sanjay Singh in particular for providing this opportunity to speak before this august audience of intellectuals. We welcome the delegates to the International Conference on Computational Research and Data Analytics 2020 and wish the conference a great success. We also welcome the eminent keynote speakers, Professor Boho Chen, Yonsei University, Taiwan, Professor Katrina Moreira, Queensland University of Technology, Australia, and Mr. Ajinkya Deshmukh, Deep Learning Lead at MathsWork. Yeah. We also thank the Suleyman Demirel University, Turkey, and Isparta Applied Science University, Turkey, for organizing this conference. It is a delight to see that about 125 delegates will be presenting their papers on diverse themes of machine learning, optimization techniques, data mining, deep learning, IoT networks, recent trends in IT, image processing, and computer vision. Well, now I would like to give you a very brief introduction of the College of Engineering Roorkee for the benefits of all the delegates. The College of Engineering Roorkee is located in Roorkee, which is about 180 kilometers north of Delhi, and is known as the gateway town to the picturesque Himalayan ranges. It has the famous Ganges Canal, a civil engineering marvel of 19th century, passing through it. Founded by Seth Roshanlal Jain Trust in 1998 as the first private engineering college in Roorkee, COER grew by leaps and bounds in the past 22 years under visionary and dynamic leadership of its founder, Chairman Engineer J.C. Jain. COER offers BTech program in 7 disciplines, MTech in 2 disciplines, MBA, MCA, BBA, BCA, BCom, BSc Agriculture, and Diploma in 3 disciplines. Well, the industry has been going through rapid changes in automation, and with the advent of artificial intelligence and IoT, the tools of knowledge delivery in an institution must also match the pace of these changes to produce industry-ready human resource. At College of Engineering Roorkee, special emphasis is laid on supplementing knowledge beyond prescribed syllabi through value-added modules of new skills and through interaction with national and international linkages to empower our students. COER has international linkages for research with the University of Texas at Dallas, USA, and the Kuban State Agrarian University, Russia. Well, with these words, I once again wish the conference a great success. Thank you so much. Yeah, I am done. Thank you so much.
Thank you. Thank you, Professor Dr. S.P. Gupta, for addressing us with your precious views and supporting the conference activities time to time. Thank you, sir. Now, I would like to invite General Chairperson Dr. Ashish Khanna from MIT Delhi to share his views with us. Sir, virtual room, I hand over to you.
Good afternoon to all the dignitaries. My friend Dr. Utku and Dr. Bekir Eksoy from Turkey, Professor S.P. Gupta and Dr. Adesh from College of Engineering, Roorkee, my friend Dr. Aditya Khamparia and his team from LPU, my fellow academicians, students, all the participants from all over the world. On behalf of ICCRDA 2020, I, Dr. Ashish Khanna, welcomes you all. Dear all, in this new era of COVID-19, when the whole world is facing the pandemic of COVID-19, the responsibility of all the researchers have increased tenfold. I would like to put light on an important point that in this dynamically changing world, the conventional systems will work now in different manner. Therefore, the role of the research community for the human welfare and the dynamically changing systems has increased tenfold. This pandemic has taught and shown us the whole world is just like a global village, and the actions of our neighborhood country can also affect us anywhere and anytime. Therefore, we all can understand the researchers from all over the world should also come together and work in collaborations, and platforms like ICCRDA are really necessary, which provides the researchers from every part of the world to come together and work in collaboration to get the fast results. Nowadays, the new gold is data, and the conferences like this on deep learning, machine learning, and the non-conventional techniques are really necessary, where all the research community people can come and discuss their research ideas. So with this, I welcome you all again. Thank you very much. Akansha, back to you.
Thank you, sir, for sharing such a wonderful views with us. Now, I would like to invite Publication Chairperson Dr. Gurpreet Singh from PIT Rajpura, MRS PTU, Bhatinda. Mr. Gurpreet Singh.
I think Gurpreet sir is not with us or facing some technical problem. So you can.
I am audible. No, he.
Oh yes, sir.
He
Please.
is with us.
You're welcome, sir.
Yes, sir. Welcome.
Okay.
Welcome, Gurpreet sir.
Welcome, sir. Welcome. Thank you, sir. Sorry, I am out of station today, so I have to connect in my car. So kindly excuse me.
It's all right, sir.
Firstly, I would like to congratulate the Suleyman Demirel University, Turkey, Isparta, Applied Sciences University, Turkey, and College of Engineering, Roorkee, India, for organizing such a wonderful conference. That is their first international conference on computational research and data analytics, that is ICCRDA 2020. The theme of the conference mainly focuses on computational research and data analytics. The first part, that is computational research, deals in this development in the mathematical modeling, simulation, algorithm design, data storage, management, analysis, computer system architecture, and high performance software implementation. There's such a vast network or vast things are there in the computational research things. The computational science is the application of computer science and software engineering principle to solve scientific problems. It involves the use of computing hardware, networking algorithm, programming database, and other domain-specific knowledge to design simulation of physical phenomena to run on computers. Computational science or computational research crosses disciplines and can even involve the humanities also. While focusing on the second area of our conference, we say that data are everywhere in the today's world, from the phones in our hand to the networks that run at our home and the communities to the scientific instrumentation that helps to us to discover the mysteries of the world. The size, velocity, complexity often make it difficult to gain the clarity and extract the values. So the term data analytics, that is the one of the theme of the conference, refers to the processing of examining of data sets to draw the conclusions about the information they contain. Data analytics techniques enables you to take raw data and uncover the patterns to extract the valuable insights from it. Then this processed data can be utilized for decision-making purposes. This process helps in business to grow, expand, and operations in their market. I hope the papers which are presented in the conference and are going to be present or has been selected in the conference will be imparting knowledge in the similar areas or in the related areas. So I would congratulate, I would also like to congratulate the Intelligent Communications and Computational Research Lab, ICCRLAB, for initiating such a wonderful conference, a wonderful theme that is the latest in the area of today's scenario. This would help the large communities of researchers, scientists, academicians, and students in gaining the knowledge in the latest area of research. I would like to congratulate all the participants again, or give my best wishes to them for their presentations. Thank you, everyone. Thank you.
Thank you, Professor Gurpreet Singh. We are really glad to have you and hear you. Now, I would like to invite our co-convener, Professor Sanjay Kumar Singh from ICCRDA.
Yes, sir. Very, very good afternoon to all respected researchers, Dr. Uktu, Dr. Vicky, Dr. S.P. Gupta, sir, Dr. Deepak, sir, Dr. Ashish, sir, and Dr. Adit Kamparia, sir. I welcome all of you on behalf of ICCRLAB and Organizing Committee of International Conference on Computational Research and Data Analytics. We have received around 285 papers, and after peer review, around 120 papers has been selected. All these papers are published in IOP conference series, Material Science and Engineering Scopus Index. Thanks all for your cooperation and participations to make this conference successfully. Especially, I am thankful to all researchers that presented the paper, and hopefully we are in contact in the future. Thank you to all. Thanks so much.
Thank you, Professor Sanjay Kumar Singh, for sharing your views. Now, we are moving towards to begin our keynote talks. Our first keynote is Professor Utku Kos. Dr. Utku Kos received BS degree in 2008 from Computer Education of Gazi University, Turkey as a faculty valedictorian. He received MS degree in 2010 from Afon Kokatep University, Turkey in the field of computer, and PhD degree in 2017 from Selek University, Turkey in the field of computer engineering. From 2009 to 2011, he has worked as a research assistant in Afon Kokatep University. Following, he has also worked as a lecturer and vocational school vice director in Afon Kokatep University from 2011 to 2012. As a lecturer and research center director in USEC University from 2012 to 2017. As an assistant professor in Suleyman Demirel University from 2017 to 2019. Currently, he is an associate professor in Suleyman Demirel University, Turkey. He has more than 100 publications, including articles, authored and edited books, proceedings, and reports. He is also one of the series editors of the Biomedical and Robotics Healthcare series by CRC Press. His research interest includes artificial intelligence, machine ethics, artificial intelligence safety, optimization, the chaos theory, distance education, e-learning, computer education, and computer science. He has also works regarding the field of literature. So, the title of today's keynote talk is Explainable Artificial Intelligence and its Application in Healthcare. I would like to invite Professor Utku Kos to start his keynote talk.
Dear Apurva, thank you very much for a great introduction for me. Welcome everybody. Again, I'd like to also thank to dear Professor Gupta from the College of Engineering, Roorkee, India, and also other friends, other colleagues for their valuable welcome ceremony speech. I want to visit India and also the places around Nepal, for example. So let's hope I will realize that so soon. After that, COVID-19 maybe allowing us to travel to the India and around such places around there. I'd like to thank again also ICCRLAB. I just missed that during my speech, but my colleague from the Sparta Applied Science University, dear Professor Bekir Aksoy, just indicated that the ICCRLAB has a great effort in realizing that event. So I'd like to thank also dear friends, colleagues from the ICCRLAB. So, dear Apurva, just indicate that my speech is based on the XAI, which is a popular subject, dear friends. I'd like to also, I will share my screen, but before that, I'd like to also share my presentation, because after such a speech, I received many feedback to send my presentations actually. So just I saw that the file button on in the messaging messenger site of the Zoom. So I'd like to share that. I hope it will be sent to everybody. Yes, it's uploading there. And if anybody having issues regarding that reach for the PPT presentation after my speech, they can send me an email. I will share my screen and let's start the speech, dear friends. Yes, I think now you can see my screen. If any issues, just let me know, dear friends. As you can see, my topic is based on the explainable artificial intelligence and its applications in healthcare. I'm an associate professor from Suleyman Demirel University, Turkey. As you can see, my email address and also my personal webpage, so you can visit them, or any issues, any ideas, suggestions, or questions. You are all welcome to send me mails, send me messages, dear participants and dear friends. And as you can see, the content of my presentation is based on just a brief introduction to the AI, and after that I will consider some important concepts which are just shaping the current and the future of the field of AI. For example, I will talk about the narrow artificial intelligence, and so that we can be understanding what is the XAI, what is the explainable AI, and other things, especially shaping the current state of the AI, and also having great potentials to form a better future for the AI maybe, and we hope the better future for all of us, for the humankind, for the Earth and the universe, of course. After talking about the essentials of the XAI, I will be talking about its some samples of applications in healthcare, and after that I will give some information about open problems regarding especially XAI. I will give some suggestions also, especially targeting dear student friends, dear degree student friends from different regions of the world. These are always key points to be being up to date regarding the advances in the field of AI. And at the end of my speech, I will take your questions. Yes, dear Apurva just indicated some about me. She has just introduced me, but I would like to also give some information about Sparta, the city of Sparta, which both universities, as you know, STU and Sparta Applied Science University, are just located there, here in that city. And also I was born in Afyonkarahisar, which is my hometown. It's very near to Sparta. It's both cities has some borders, common borders. It's around 2 hours via car. And as you can see, Sparta is famous with its roses and green areas, and there are lots of lakes here. And you are all welcome to visit Sparta, of course, around this region. And also Afyonkarahisar is famous with also starting point for the independence war of the Republic of Turkey, and it has lots of historical places. It has a big, very big rocky castle inside, in the middle of the whole city, as you can see. So you are all welcome to both cities. Of course, you are all welcome to visit Turkey. There are many different beautiful cities. As the Sparta, the city of Sparta, we are very near to the Antalya, to the seaside of the Antalyan seaside on the south side of the Turkey. So we are all welcome to visit Sparta. So you can also dive into the sea when you have time, to a very near time by going around 1.5 hours via bus or car. And I would like to also give some information about the STU and also Sparta Applied Science University. My colleague, dear Professor Bekir Aksoy from there, we have just joined to form a great force with the Engineering College of Roorkee from India, and also with the ICCRLAB to realize that such great event. We are looking forward to having more collaborations in the future, of course. As you can see, there is the logo of rose inside the logo of the STU, because as you know, the city of Sparta is famous with its roses, so that appears over the logo. And Suleyman Demirel is one of the former presidents of the Republic of Turkey, and he was born in Sparta, so his name also appears over the STU. STU is a public university established in 1992. It was the only university in Sparta, but another great university, Sparta Applied Science University, was just established in 2018. As the STU, we are known as a large academic institution with agricultural research, medicine, engineering, and also business science. And on the other hand, my colleague, dear Bekir Aksoy, knows better than me, but I'd like to just give some brief information about the Sparta Applied Science University. It is the second public university established in 2018. And it's a very fast-growing research institute, as focusing on especially vocational programs, technical programs, and programs regarding water research. As you know, there are lots of lakes, as I showed in the previous slide, and because of all of these lakes, we have some research regarding the water research, considering all of different topics inside the research of water. So both universities are also very famous, but the Sparta Applied Science University is more famous with its research regarding the water works. And also we have very strong collaboration, of course, as locating in the same city and very near places in terms of campus areas. So we hope the best for the rising or providing better research, better projects for the technological developments and for the scientific audience. So as both universities, we would like to thank such a great collaboration with our friends, our colleagues, and dear respected professors from India to realize such a great event. And as I've said before, we are looking forward for having more great collaborations. Yes, and also we have inside both universities, we have Department of Computer Engineering departments, and also my colleague from the Sparta Applied Science University, dear Professor Bekir Aksoy, is from the Department of Mechatronics Engineering. So you are all welcome to visit our departments and universities. We are hosting international students, of course, in terms of Bachelor of Science, Master of Science, and also PhD degrees. So we are all welcome to visit our technical programs in terms of all of these topics covering the computational techniques and data analytics are very important for the engineering fields. So you are all welcome to visit us. Yes, let's start finally. I would like to give some brief information about AI. Actually, everybody is having some essential knowledge and background about that field. I hope, as you can see, there is the guy, the Professor John McCarthy from USA. He is the father of that term, the artificial intelligence, as coined it during the conference in Dartmouth, USA, around 1956, I remember. and he just defined that field, that concept, as the science and engineering of making intelligent machines. When we talk about science and engineering, we just talk about both theoretical and applied sides of the same thing, for example. So it's very important. As you know, there is the theoretical physics and also applied physics. So in terms of computer science and the many other subfields rising from that computer science, we should be talking about both theoretical and applied science. Of course, the reality is the applied things, so we should be having enough knowledge and abilities, of course, to develop something intelligent in terms of the field of AI, and in terms of course, different areas of engineering. So we can say that the concept of AI is somehow a simulation of humans, animals, and the nature, as inspired from all of these things coming from these the nature, actually, because humans and also animals are taking place in the nature. So we just rise some or develop some technology-based intelligence solutions to deal with the real-world problems, and just using them, we just try to solve the problems with a more efficient and effective ways, or we can just run some intelligent solutions for the problems which were not solved by traditional methods, or with the abilities, limited abilities by the humankind, for example. So we can say that it's the science for the current and the future, for the today and the future. And it's also a multidisciplinary science which has great relations with the different science in terms of especially informatics, information and communication technologies, computer technologies, electronics and mechatronics, and maybe the other engineering fields. And of course, there is the background regarding the mathematical and logical side. So that is the one of the points that especially students are fear of when starting to know something about AI. But don't worry, be happy, dear friends. You will be not an expert of mathematics, for example, or statistics, or the modern logic. Of course, anybody coming from these fields will be having more abilities to adapt very fast to the field of AI. But the mathematics and logic is just the starting point. You can be learning while examining or applying different techniques coming from the field of AI. So don't be fear about that. And there are lots of discussions regarding that, as you know, if it's an utopia, if the AI is an utopia or dystopia, and if it will be a technological risk or threat, if it's a trustable systems formation for the humankind, especially. And I think especially not only us, not humans, but every living organisms over the earth will be or is experiencing such things. Just think about COVID-19 and its effects, not only humans and also animals. Actually, the nature is better, maybe because of the humans have locked down in their homes, not affecting the nature too much. But we should be having a balance in terms of that earth, that environment we are sharing with different animals and other living organisms. So such technological things like AI are taking place in such discussions regarding that, especially technological risks or cause of existence. And everybody says that if it's a stoppable technology or not, or it's an evolving technology by its own efforts. But at the final, we can say that the field of AI and the intelligence solutions are just the products by the humankind. So we are all having the responsibility to shape such technological components to be providing positives rather than negatives for especially humans, for the universe, for the earth, for the other living organisms. Yes, when we talk about the AI, it's has a very deep historical state, as you know. We can be just talking about the automatas or imaginations by the humankind when we talk more about the historical state of the AI. But when we talk about the current topic, about the XAI, we should be talking about what is the current state of the AI, what is the conceptual explanations regarding the current state AI, and what is the feature will be giving us, or as just probably giving us in terms of the future of the AI. For example, when we talk about the current algorithms or techniques in terms of field of AI, we should be saying that these are all weak techniques or weak algorithms trying to solve some problems. At least they are very successful in providing great and positive outcomes for the technological developments, but they are just limited. When we talk about outperforming humans in specific repetitive or tasks in routines, for example, and for example, medical, when talking about the medical diagnosis or giving some advices in terms of decision making, they are very successful, but they are still very limited. And so because of that, we are just defining the current artificial intelligence as the artificial narrow intelligence. It has a narrow ability and narrow solution scope when we think about, for example, emotions or other things, when we derive some solutions, analyze the exact problem we are facing, and making synthesis regarding some solutions to deal with the newly encountered problems. We just run some already known data or instant experiences in terms of the reinforcement learning, maybe to develop or to train some machine learning algorithms. And we also have some different rule-based techniques or maybe optimization algorithms to run them just a limited scope of the problem modeling. The modeling is very important, but the mechanism provided by such algorithms are limited. So we call the current techniques and algorithm or the current state of the artificial intelligence as the artificial narrow intelligence. But what is next? What is next? The researchers and the scientists around the world just think that around 2040, and maybe I think the COVID-19 maybe just shortened that time period or affected that time period negatively to maybe just adding a few more years to reach such advances in terms of AI. But at least the audience, the scientific audience, have some additional concepts in order to explain future states of the AI. For example, just talking about artificial general intelligence, we can say that around 2040, the abilities of the intelligent algorithms will be reaching to a level that's allowing them to competing with humans across all fields, all tasks. For example, like earning a university degree without giving some support with the humankind or forcing them to perform some additional tasks and very big errors eventually. But around 2040, the artificial general intelligence or AGI will be performing very broad tasks by analyzing the problem, by shaping some or creating some solution steps, like, for example, buying something from IKEA and reading something from the guide from the paper, and after reading that, just building the maybe table or chair, but its own only efforts, not with our support, but not with a modular solution, but just running its own mechanisms, solution mechanisms by itself. So that means that although we have the jobs improved currently, the jobs will be at risk when the artificial general intelligence will be real. And when we talk about the further side after the artificial general intelligence, we just reach to the artificial super intelligence. We can call as the ASI. It's a term coined by the professor Nick Bostrom from Oxford University, from Future of Humanity Institute. He is a philosophy professor of the philosophy, and he says that the artificial intelligence will be reached to a level which just demonstrate intelligence beyond human capabilities we already know. And that means that not the jobs will be at risk, and the humanity will be totally all risk. You can be referred to Google Scholar or other the indexing services or searching environments by using all of these keywords to search more about these concepts. the future is blurred for now. It's not clear, of course, but there are some theories like that artificial general intelligence and super intelligence will be having not only positive and more negatives for the humanity. So we will be, or we should be giving some instant solutions for having some precautions before such artificial intelligence versions will be appearing in the future. So that takes us to different concepts, of course, like XAI. For example, when we talk about weak AI and strong AI, it's not a certain thing that when we get up, we will be all seeing the artificial general intelligence, but it's a time period which is rising a little and a little, just like the boiling some water when the frog is inside the water. So it's a very critical thing for the humankind. So we should be having some the additional precautions inside the weak AI for now, at least. So when we reach to the strong AI, which means artificial general intelligence or artificial super intelligence, we will be having safe intelligence systems. For example, when we talk about AGI or ASI, we can say that they will be able to understand abstract concepts or explain why. So we will be just doing that actually. So I will explain that during my speech inside the next slides. And it's thought that the AGI will be creative like children, or telling right from wrong and having emotions. These are all, except from the explaining why, these are the other things are very new things for the AI. Actually, the researchers are examining such topics, but although as the humankind we have not actually known the meaning of the emotions in terms of mathematical or logical explanations, of course, how the AI systems will be having such capabilities or abilities to run different solutions like they are humans or the, something like the other animals or living organisms. So that's a very critical thing that if we have such new concepts of AI in the future. But many or majority of the scientific audience believes in that. And the majority of the scientific audience believes in that we should be having some precautions before we are reaching to such level of revolutionary levels of the field of AI. And also we have the ambient intelligence, for example. That's actually not a very new concept, but it's just a concept rising thanks to IoT or the other hardware-based intelligence or smart solutions we are just using for nowadays. Actually, it's somehow the ambient intelligence is the explanation regarding the software or the decision-making side of such systems raised by IoT or IoE or IoHT, maybe just talking about some hardware-supported things, trying to give us a better life while we are doing something during the daily life, for example. So ambient intelligence is another new concept of the AI, explaining that there will be many things surrounding us in the near future or the far future, but they will be all responsible to make everything in a communicating manner, machine to machine or the IoT manner, maybe both of them in a hybrid method. But at least that concept explains that the life will be supported by such intelligence backgrounds in terms of talking software side of such hardware-based solutions. So it's somehow a definition or abstract definition or abstract background of the systems like IoT or other things. So that's another important point. You can be searching for that over the web. And finally, when we come to XAI, which is the main topic of my speech, we can be saying that the traditional AI solutions are widely used in all fields of the modern life, as I've said before. But for example, these fields include the medical, healthcare or other critical fields which are very associated with the way of the human understanding, for example. So when we talk about even in terms of deep learning, today's advanced machine learning techniques are generally black box. What does it mean? That means that actually the early traditional techniques and methods of artificial intelligence can be explained in terms of having a good outcome or trustable outcome when we think from a human perspective, and when we think about the balance between the inputs and the outputs that the intelligence system is giving. The traditional machine learning algorithms or techniques are just somehow transparent techniques, not totally transparent, all of them, but they have just some include some mechanisms which we can just use some numbers, some parameters to see that if our system is working good and giving us trustable outcomes. For example, you can be having some outcomes as a chance. You maybe say that, yes, that system just gave us some successful results, but what is next? When the next time you are running that system, can you say that it's a very trustable system that's giving the or having the stable outcomes and stable solution mechanism, and it will be always giving us trustable solutions in terms of its decision-making mechanisms? We cannot say that. At least when we talk about deep learning, the techniques and the algorithms have more parameters which we can call as the hyperparameters, for example. So the more we use data, the more we use deep learning or somehow advanced forms of machine learning, so the more we reach to black box techniques, which means not something like protected with copyright issues. It's another thing, it's a different thing. The black box here means that you cannot be reaching to exact the mechanisms, inside mechanisms or parameters of the technique in order to see if the outcomes are trustable. There are, of course, many hyperparameters. You can say that there are many different parameters we can be using, but these parameters doesn't mean that the input is or the output is trustable when we make connections with the input the system is using. We should be having more efforts to understand and to explain a few parameters only in order to reach to the explanation side which the humankind understands. So that's very important. And we should be trusting such systems without having angsties in terms of black box systems. So that's not possible always. When we talk about healthcare and medical, we cannot be trusting totally all different intelligence systems. For example, diagnosing COVID-19 or cancer or performing other tasks. It's not guaranteed that your system will be giving very bad outcomes next time. So we should be having some trustworthy explanation side in order to understand the limitations and future states of such systems. But that is actually in terms of the human view, that's associated with the term of the interpretability. And when we talk about interpretability, we reach to a new concept called that explainable AI. And we can just briefly say that XAI. That is just achieved by extending some rule-based or expert systems-oriented AI models in order to explain the exact mechanism running on the background of your system. The combination of that, all of these related efforts are combined under the new research area, which is officially called as explainable AI. As you can see, there is the growing literature regarding the XAI. For example, the XAI, the term of the explainability or the explainable, that word is just a new thing, maybe around coming from 2014, or we can talk about the 2017 maybe. But the interpretability of the intelligence systems just leads to around 8 years time period when we talk about in terms of trustworthy, it's a very deep historical state. It has a very deeper historical state. But when we talk about explaining current systems, especially including deep learning, we can be talking about a 8-year period coming till the 2020. But during the more research efforts regarding that, it has just transformed into a new concept called as explainable AI. You can be just both using the interpretable artificial intelligence and the XAI words for explaining the same thing. But as you can see, the exact thing I am trying to explain here, that the research efforts, research works in the literature are growing fast in time. So you can be taking a look at to that sub area for your further research. And when we talk about more detail regarding the explainable AI, I have just said that, for example, today we have just, in terms of machine learning techniques, of course, we have just some training data, we have just machine learning process inside or the middle of the data and the outcomes. We just have reached to a learned function or learned technique at the final, but we cannot ask such a system that why did you do that, or why not something else, or why did you succeed, and when do you succeed or when do you fail. We cannot ask such questions to the system. Actually, as long as we have not developed or coded such systems, that they will be not able to explain such things. But taking a look at from the human view, we are not able to have some ideas for the answers regarding all of these questions. So that's a very critical problem. But when we talk about XAI allows you to add some modular techniques inside or in the middle of your current machine learning technique. So it can be explaining some parameters by using some parameters or some other different outcomes coming from the exact solution mechanism of the system. So you can understand why the system that system has reached blah blah solutions, or why not it has reached to something different, and when has reached to some solutions as a chance or with a totally trustable relation between inputs and the outputs. Of course, when we talk or dive into deeper side of the XAI, when we talk more about that concept, we should be thinking about different sides. For example, details of your problem or reasons to run some XAI systems. For example, thinking about healthcare and medical regarding my speech currently, your reasons are very important, because you should be having something intelligent which is very trustable in terms of making diagnosis which is affecting to humans actually, or other living things like animals or other organisms. So or when developing or creating some treatment strategies or developing some vaccine or drugs, for example, you should be saying that yes, my system has just such things, but we should be trusting that system, so we can give such drugs or vaccine or some treatment strategies to the patients with a totally safety, for example. So the transparency is very important, the scope of your problem is very important, and the more of all of these things, the HCI side leading to the user side is very important. I mean the human-computer interaction actually. By using the XAI, we just improve the human-computer interaction side. So that includes the very careful development design of the interfaces, very careful modeling of the explanation side, and hitting exactly the user in terms of making or explaining explaining the system in terms of talking about system, explaining yourself to the human with a totally trustable way. So these things are very important. And when we take a conceptual look at to the AI, actually some of early traditional algorithms of the machine learning are able to very easy to being interpretable or being explained with additions. For example, talking about simulatability, you can be just using some functions or some parameters. You can be able to see inside the system when it has trained and when it is providing you some outcomes. It's very easy to interpret. You just can be using some human side rules to understand, to make it and understand and make an explainable interface after taking such outcomes. And if you just pass a little to the black box side, but not too much, you reach to decomposability. That means you have also opportunity to add some additional rules, but in terms of human side, you should be somehow transforming some parameters to the near of the parameters you are explaining exactly in the real world. For example, talking about weight and height or age, your system may be using some a few more parameters to combine all explanations regarding, for example, age or height. But you should be having an additional efforts to transform them to make them explainable to the human side. And when we pass to the black box side a little more, but keeping a little transparency still in terms of traditional algorithms, you reach to algorithmic transparency, which means you can be using the rule-based systems at this stage, and by having some more efforts regarding the rules, you just try to provide some explanation interface to the human side. And when we totally pass to the deep learning side, when we totally pass to the black box model side, you have different types of strategies to make your system explainable. Of course, these are all regarding to, for example, visualization. It's not a way of the explanation. Of course, it's a way of explanation, but not hitting the exact technical side of the model. But it's very important when we talk about human-computer interaction. And we can also have some local explanations by catching a few parameters which are not affecting the explanation side too much, but having enough information to for the humankind to understand and explain the problem solution side. And also you can be using some feature relevant connections, and you maybe use some examples to explain your outcomes of your system when it just provides some diagnosis regarding a certain cancer, for example. You can be use some human side coming, some cancer diagnosis to match the outcomes, to match some parameters or input and outcomes. So by having some connections between the human side interpretation and intelligent system side interpretation to make your system explainable. That's somehow some human support, of course, but it's the thing that's included in the literature of the XAI. Also, you can be explaining something by explaining them in terms of texts, by using some numbers and transforming them in terms of text, which means understandable in terms of the linguistic means by the human side. And also you can be using some additional techniques to make your system more simpler to be explained. Of course, it will be running a deep learning, but you will be using some additional models to explain some outcomes by making the system simpler in terms of parameters or other things. And of course, that leads to us a hybrid model, especially the last one I mentioned. And currently, there are many different efforts making hybrid models for explaining black box models. People just add some decision tree or rule-based learning side or KNN to explain some parameters coming from the black box model, which means deep learning, actually. So, for example, there is using heat map, a very remarkable strategy to make that. There are some algorithms to add some additional algorithms inside or to do your deep learning techniques. So when your system just predicted a photo by saying that yes, there is a dog inside that photo, you just run some additional algorithms in order to run some visualization techniques, some image processing based techniques to provide some heat maps over the input image. So as you can see, by using the level of the different heat maps, heat regions, we can say, you can be understood that your system is good in terms of understanding that there is the dog, because it's looking or it has just looked at to the nose, to the ears, and to the head side of the dog. And there's another example here, as you can see. And there is also somehow different visualization techniques for black box techniques. For example, when your system says that there are two animals inside the photo, you can be just running some image processing based techniques to to make visualization regarding some outcomes and connection between pixels and the outcomes, so you can be reached to such view, and you can understand that your system has just seen two animals inside the photo, and it says just the system has just explanation site has just drawn some different colors, indicate that all of the explanations or the reasons for that decision are that all of these pixels, for example. And when we talk about, for example, lime, there is the lime, L-I-M-A. You can search for that. I cannot answer, local interpretable model agnostic, something like that. I cannot remember for now, but just write lime and XAI over the web, and you will be reaching a very remarkable algorithm to explain the black box systems. It just uses some additional efforts to explain or to visualize, make some visualization regarding outputs of the neurons, for example, inside your system. In terms of talking deep learning, that can be a visualization of the output of a neuron, for example. And when you go through a wider view of the picture, you just reach to the bigger picture. That's just an example. That's not an explanation, actually. That's the result that the system has just build up some new pictures, some image by using some already known data, actually, like drawing some new paints by using the style by the Van Gogh, for example. But that's the result. But by using lime, you can be taking a look at to the details in order to understand, yes, in the atomic style, your system is successful in order to combine all of these things to draw up the whole picture at the final. That sample may be given by using some already known image, created better image. That's the image for the deep learning, but that's somehow abstracting finally. And also the lime also allows you to explain some different size of your photo input image by locating some local explanations. As I've said before, the L is coming from the local, the word local. And I remember that it's coming from the interpretability, I think. But at the final, that technique allows you that when your system says that there is a guitar and the dog inside the photo, when you just run an additional explanation interface, it says that, yes, I found the electro guitar with the probability of around 32, for example. But with a probability of 24, I also think that there is the acoustic guitar inside that photo. By combining these images and looking at to the regions, to the pixel combinations, as you can see from the image, you can be understood that, yes, my system, at least the probability seems low, maybe, but at least my system just reached to the guitar recognition by looking at to the true side of the image, for example. There was also dog example near to that image, but I think I missed that inside the presentation. But also there is the Labrador site as a third image in addition to both of them, and it says that, yes, there is a Labrador, not dog only. There is the Labrador, and I show that that recognition from that region. It says that with an additional third image. So that's very critical, as you can see. The explainable is done in terms of, at least for the black box and for current solutions. And transparency of different techniques at this point are very different. In order to use my time, I don't know, I'm talk too much. I think in order to use the time more efficiently, I will just forward you a paper about that. All of many of these images are because taken from a very remarkable research work published in 2020, and you can take a look at, by looking at that image, you can be understanding that how to explain decision trees, how to explain KNN, how to explain rule-based systems, or maybe generalized adaptive models or Bayesian models, for example. sorry, in terms of Bayesian models, for example, you just use some Bayesian probability outcomes in order to make explainability. And because of that, these things are very widely used inside the self-driving cars, for example. When you try to explain the actions inside the self-driving cars, it's very easy to explain actually. But of course, there are also deep learning techniques and flowing many hyper parameters inside the car. So you should be having some more efforts, but going around the Bayesian models in order to understand if your car is trustable in terms of decision making. And when we talk about the medical application side, healthcare applications, I refer you to some publications from especially Nature journals. For example, there is that work coming from the 2019, an XAI deep learning algorithm for the detection of acute intranasal hemorrhage from small data sets. It's very important that it uses small data sets, and at the final, it explains the diagnosis by using heat maps, as you can see. There is also some graphical explanations, findings inside the paper, but the most remarkable one, considering the XAI, is the using heat maps to explain its diagnosis by using the input image. As you can see, there are many different problems explaining the hemorrhage from the image, that medical image, and the heat maps are just hitting the true side of the image, just like the doctor is looking at, or radiologist just looking at the same image and considering the places shown with the heat maps. And when we take a look at the AI in medicine, it's a good journal. We can see that there is an example of breast cancer diagnosis with the case-based reasoning and interpretability side, for example. It's a more understandable technique except from the deep learning. Actually, it just uses some classification, and after that, by using some queries and making connections with the classification results and some parameters from the system, it just uses some visual interfaces to explain the outcomes. When we take a look at the explanation side from the human side, it's very important in order to ensure a good interaction between the human and the computer and the AI. It says that I have reached to blah blah solutions because, for example, tumor size is bigger than the 20, around 20 or 90.5, for example. So you'll be understanding that, yes, it has detected the tumor size as the important side of the diagnosis. So it has reached to that result. And according to their importance, it just uses an additional graphic, as you can see. And also talking about, again, nature site, nature communications, there's such a system. And inside that solution, they use just layer-wise relevance propagation, which is just an addition to the known propagation algorithms inside the multi-layer neural networks, and making use of the weights and making an addition of simpler explanations regarding the weights. Actually, how can I say, just transforming the current many big number of weights to a low number of weights in order to understand how each of the inputs of the neural networks have made or reached to the outcome that we have just reached to, for example, acute kidney injury at the final. By using that interface, that visualization interface, it says that, yes, I have reached a diagnosis of kidney injury with a total of percentage of 78, but that's because I have catched the peak creatinine from the input, and I have catched the high value from the kidney eGFR, so I have reached to that decision. That's very important. Actually, that's coming from the weights, as you can see, that is just achieved thanks to layer-wise relevance propagation in that publication. So you are just explaining the input-output relation by just using some weights, which are actually optimized in terms of training, of course. What are the other things to explain? Nothing. Just weights are used to make the exact explanation for your system. And these are different scenarios from the publication. And there is also another one from 2020 from +1. It just uses some model selection based, which is not very black box, but a little transparent system. And by just using some model and weights or some parameters coming from the model, it's just reached to an individual metric scoring, which means it's a simulation based training in surgery and medicine. It says that yes, you have failed in that test during the simulation based training, but that's because you have just yes, you have reached to that point, but because you are failed in that, for example, safety assessment task, you have failed in that training, or you have succeeded, or you have been skilled in terms of system because of all of these parameters. That's another example. And a simpler example, because it uses decision tree, it's very easy to interpret because it's all coming from the way of the tree, and it just uses some numbers. Maybe you can be make some transformation between values and the linguistic terms in terms of humankind. And it's the assisted and incremental medical diagnosis using XAI in order to diagnose again kidney disease, for example, critical kidney disease. And what is the confidence? For example, it's 96%, but it recommends that because of the hemoglobin test, actually, or it has just reached to that because of another confidence value, because of the red blood cell count test with a confidence with the 98%. And by combining all of them, it's just reached to that diagnosis. Just yes, CKD is detected. But I suggest or I explain my outcome by using all of these confidence values with the related inputs, for example. That's another very simple example for that. And also it uses some additional interfaces to the human side, because when you show that, again, some humans or some doctors or maybe users again find it difficult to understand, but the system just uses additional efforts to locate an interface which is totally making the technical background not visible to the exact user side, who are not very interested in the AI side, but interested more about the trustable side, for example. And there is another one. It's just coming from the repository arXiv. It's just very interesting understanding and interpretation of ML in prediction in clinical gait analysis using XAI, for example, by taking a look at the gait data. It just says that yes, there are some blah blah problems, and it just uses some graphical interfaces in order to explain with a something like a heat map, but by using some colors inside the graphic, for example. And also there is another one from Plus Computational Biology. It's very interesting, like making research regarding social networks, as you can see from many different research works, social media analytics. And it says that the relevant GAN explanation regarding the identification of some problems, for example. It just uses some some connections in order to explain all of these complex GANs to explain some connections. And yes, let's reach to the final. I hope you are not bored because of my long speech. Sorry for that, dear friends. Let's talk about open problems and suggestions, and after that I finish my speech. Open problems are still alive because that's a very recent and new field. For example, you can be researching for the target user's characteristics, because, as I've said before, a doctor may be understanding something from the decision tree view, but another doctor may be not understanding enough from that decision tree view and needs from a better view in terms of web interface, maybe, or other mobile based interface with some buttons and some simple graphical interfaces, for example. So understanding user characteristics and making an adaptable XAI may be an open problem. And of course, data is always open problem when you perform some research works in terms of AI. And also which techniques to combine for explainability is another open problem. And the target problem is important. Performance and optimization is also important. When you try to explain some cancer diagnosis by just passing some 2 or 3 hours to reach to explanation, it's not a good point, I think. So because of that, you should be having some efficient systems in terms of performance in order to deal with the human side when we talk about from the AI side. So the performance and the optimization needs for a better performance are important open problems. Of course, user experience is important when we talk about XCI and when we talk about current software developments. It's very important. Transparency is important. Reaching to transparency is very important, as you have just seen. And ethical issues and safety are very important when we talk about ethical issues. For example, there may be some discussions regarding copyright issues or sensitive personal data, because you just try to manipulate some data and you always need some parameters coming from black box systems. So some maybe companies or some people maybe not feel trustable when you want to use the data. Of course, you just try to make your system trustable, but using of such sensitive data maybe not good, welcomed by the people, of course. And that may be another open problem when we talk about social impacts, of course. And of course, problems in target fields will be shaping the future of the XAI, and software-hardware combination is very important. For example, XAI for IoT is very important when we talk about such systems in terms of cybersecurity, and the more in terms of having a trustworthy system for understanding of the human side. And let me to give some suggestions at this point. It's very important to learning something about philosophy of the AI and its essentials, of course. And learning the algorithmic details of AI techniques are very important. Actually, these suggestions are more hitting to the needs by dear student friends, I think. But for example, I always suggest that during my lectures and webinars, write your codes manually at first, not using directly libraries, for example, in order to understand the actual logical background of your model, because currently you have or everybody have many different types of components, libraries to use directly to reach the solution. But as long as you do not understand logical background of your system, you will be not able to raise your further solutions for different problems. You should be understanding the logical background regarding the machine learning or the other techniques. Yes, dear professor.
Yeah, I'm sorry, I'm interrupting you in the wonderful talk which you are giving. Actually, if you can just wind up a bit fast, if possible.
Yeah, sure. Just
according to the schedule, we are the second keynote is
certainly. Sorry for that.
No, it's all right. This is it's a really insightful, and it means you are giving wonderful speech, but we have some time constraints. Thank you so much.
We shouldn't
please
take
make your time, and you can just wind up. Thank you.
Sorry. Thank you. It's just 1 minute, I think. Yes, and you should be writing your manual codes first to understand the logical background, so that you will be an AI expert if you run such things. And of course, when we talk about deadlines and private and public sector, you are free to use libraries, but in order to understand the exact thing, just write your codes manually. And learn about interpretable techniques and hybrid modeling. Of course, that's very important. Learning about data statistics are also important. Learning some about mathematics and logics are very important. Joining to such events, massive learning programs are very important. And reading not only from AI oriented news, popular science sources, but also reading publications from scientific sources are very important. Combining them are very important, not only reading publications or not only reading popular science from blogs or other things, but combining them are very important. And just follow some famous scientists to understand what is actually doing and what are open problems and what will be predicted to be in terms of the future of the XAI and also field of AI. Yes, thank you very much for listening to me, and sorry for the long speech. Let me to say that yes, that is the exact publication by the Arieta and his friends from the Information Fusion Journal. All of the many slides and images are taken from that great work. In order to understand the concepts, taxonomies, opportunities, are many other things in terms of an essential introduction to the XAI. Just refer to that publication after my speech, and after that event, of course, just listen to others' speech also. And sorry, dear professor, coming after me, dear professor, sorry for taking your time also, and sorry all of dear listeners. I hope you enjoyed my session, and your questions are all welcome. And also, in order to use the time more efficiently, you can send me your questions if we have not enough time to take your questions. Thank you very much.
Thank you, Professor Utkukos. Thank you, Professor Utkukos, for giving deep insights of explainable artificial intelligence and applications in healthcare. It was really great presentation. Thank you again.
You are welcome, dear.
Our second keynote for today's session is Professor Boho Chen from Yonsei University, Taiwan. Boho Chen received the PhD degree in electronic engineering from the National Taipei University of Technology, Taiwan in 2014. He is currently an associate professor with the Department of Computer Science and Engineering, Yonsei University, Taiwan. His current research interests include computer vision, closely integrated with deep learning, autonomous vehicles, knowledge representation and reasoning, and human-computer interaction. He was a recipient for involvement in research with the Department of Cybernetics at Tula State University, Tula, Russia in 2014. His keynote talk is about image dehazing, progress and challenges. I would like to invite Professor Boho Chen to start his keynote talk. Please.
Okay. Hello, everyone. Can everyone hear me clear?
Yes, sir.
Okay. Can see me okay? Okay, let me share the screen first. Okay. So, at first, I would like to thank you, the community, to holding this wonderful event today, and of course, special thanks for my friend Dan from Vietnam, who invited me to this wonderful event today. So today, I'm so honored to attend this. Conference ICCRDA 2020 and present some keynote here entitled as the image dehazing, progress and the challenge here. Again, my name is Boho Chen. You can call me Dr. Chen. And oh, sorry, I should do that. Yeah. Okay. Again, my name is Dr. Chen. You can call me Dr. Chen, and I come from Taiwan and come from University, Yonsei University, Taoyuan, Taiwan. And just a little bit introduce of my university. You can, my university is at the place Taoyuan City nearby Taipei, and is the not very big one, but a very beautiful one. Yeah, so we have lots of international program here. So welcome everyone to join us. So this is a little bit advertisement at first. So today, I know the time is a little bit late, so I just need to quickly finish that as possible as I can. So. First, today I will talk lots of the image dehazing ideas. So first, I will need to formalize this image dehazing problem first. Then I will try to I'll try to give you a little bit background of this topic, and I will try to explain current research in image dehazing. Especially, I will in this talk, I will divide this existing work into 3 branches. The first will be additional information approach, and the other 2 is a single image approach and the data-driven approach. So finally, I will try to give you some possible direction in who may be interested in working in this field. So the haze and the fog, or sometimes we call it smoke, these all are the phenomena that caused by absorption and the scattering of these medians to the light. And this kind of median can be like something like a particle, or sometimes it's a tiny water drops in the air. So this can result in very the effect looks like the photo I showing here. This was the photos. These photos are captured by myself by my cell phone in the morning when I was in Los Angeles in 2019. And it's true, indeed, these things happen in our daily life, in our life. You know, sometimes this kind of a thing, maybe it's kind of a sometimes you say haze or fog, this kind of weather, maybe it's a little bit like a fairy tale, but it's indeed this is actually happen in our daily life. And what this gonna cause the problem. This gonna cause lots of problem to the image computer vision application, especially when you try to recognize something from this kind of image. For example, like from the left hand side, I just show you some image that we just try to put hazy image into the Google Cloud Vision. And using Google's API, we try to get something back, some object, and do some object detection. We try to get some object back or some label back. But unfortunately, you see as a Google API return to you that answer that just only some labels called maybe this is some asymptotic phenomena or fog or haze, or even they say this is sky. This is totally wrong, right? At least we can barely see something, some bench inside, but this is definitely not the sky. So this can cause lots of false alarm to this kind of computer vision system. So if we put we try to remove this haze formattation out. So and then we put this haze-free image to the Google API to try to do the object detection again. So we can see Google API this time. Google API just give you answer that there are lots of bench here, and even you can see in the background there is tiny bench. They can even detect that from that, right? So this is totally different results from the Google API give to you. So as you can see, this kind of a hazy situation is kind of very difficult and make a lot of difficulty to the computer vision application. So if we try to deal with this remove haze formattation, we need to somehow we need to do we need to formalize the haze image first. So on the right hand side is a scene gradient, and the left hand side is the where I take the image and where I see the image. So from the light will transfer from the scene gradient to pass through the lots of median transmission and just go to the camera where I using my camera, where I observe my camera. Okay, so during that in between the scene gradient and my camera, this path can form lots of the scene gradient inside. The scene gradient is formed by the lots of different particle and the water drops, and each of them, each particle can do absorption or scattering to the light. So this result in this kind of a blurry. On the left-hand side, you see a blurry and a little bit fuzzy situation, and washout situation, washout effect in this observed image. So in computer vision, usually we will try to we need to try to describe how the formula, we just try to describe this kind of formutation of this kind of image. So usually we're using this equation here. I show you here. So I here is kind of like the hazy image, and the observed image is kind of usually hazy. So J is a singularity, and usually it's haze-free. And A will be the global spherical line, and usually we call it line just for short and better to pronounce, of course. And T is kind of the median transmission that describes lots of the light from the singularity to the camera. And lots of the different usually it's kind of describe the haze density in this kind of transmission. Okay, so here is for better understanding this equation. Let me visualize one example here. So you can see, as you can see that the this is a hazy image here from the left-hand side, and this is the transmission. What we try to get, this is like something like a haze density, and this is a singularity, right? On the right, on the middle side, this is a singularity, and this is a line. This A line means the most strong part, most dense part of this haze density. So if we have the haze image, and we have a transmission, and if we also get the airline, then we can very easily to get the singularity back, right? So this is just a formulation of this hazy image. Basic idea of how we try to get the singularity back. So as you can see, this transmission here is kind of like related to the actual sync depth, right? So it's almost the sync depth, but not the sync depth. It's kind of like it's potentially because this equation is kind of like potentially accumulation potentially with the depth. So we can see somehow if we can get the transmission, then maybe we can still recover the sync depth to some unknown scale, because we still need a beta here, the scaling coefficient, this kind of a different unknown scale, but at least we can get some similar some close information close to the sync depth. Then we know lots of the idea, because from here we know the most important thing is to get this kind of transmission. If we have transmission, and of course we also need an airline, but the most important thing is to get the transmission. If we get the transmission back, then we can remove the different we can remove this haze formation. So in the past year, lots of the different image detecting method has been proposed to eliminate this kind of blurry washout effect from the hazy image, and try to provide much more detail, so that the computer vision application can recognize things recognize things in this image, this hazy image, right? So usually we will try at very beginning this kind of research, this kind of topic, this community. Lots of people try to using additional information approach to predict transmission back. So they either using the multiple image to synthesize some depths, or using noise 3D model for a given scenario, and to try to build some transmission back. And also, even crazy things is some work even try to asking user to give some assistance try to recognize the sync depth and using the sync depth to remove this kind of hazy formatation, hazy particle. So as we can see, this kind of depth information is not easy to get, especially when you have only single image. So single image approach is even harder, even challenging that. So if lots of work, lots of research focus on this kind of topic using single image to do that. So even recently, right now, because the power of deep learning, right now we have many data sets. So right now, what we trying to do is trying to lots of researchers trying to invent something, some kind of data-driven approach in this community. So today, I gonna only focus on single image approach and the data-driven approach because these are two main branch right now while we currently doing the research in this dehazing community. So before I talk about the single image approach, let me elaborate the prior this terminology in image dehazing, because somehow in this kind of term prior in image dehazing, somehow it's not easy to understand. Even I try to explain that in Chinese, it's not easy because this term is the kind of spatial meaning in the image dehazing. So, for example, like we know this equation from the left-hand side. We know this equation. We got this is kind of like a opposite problem, right? Because at least we have two unknown coefficient here, unknown parameter here. So on the right-hand side, as we can see that we have if we know the t and the t and a and the I name, we can very easy to get the z back, the sin gradient back, right? So this become, if we know this, at least we have I, and if we have some good summation to A and T, then maybe we can change this opposite problem to a well opposite problem. So the way you trying to get these unknowns, we say this is prior. So usually the prior meaning the way we trying to get these unknown things. Okay, so I gonna start from I pick up this very famous and preemptive idea in this single image approach. First one is doctrinal prior. The next one is the color attenuation prior. Both of these approach are famous and useful and give lots of the idea to the further research. So right now, first I'm going to talk about doctrinal prior, and this idea is very interesting that they say maybe based on one observation that a very low intensity will exist within one local patch if this is a haze-free image. So for example, like if you see, we try to using this haze-free image and to calculate this image star channel. So we can see on the right-hand side here, it's almost completely dark, right? It's very dark. So it say, let's also say that this is a dark channel of this image. So if this is a haze image, then they say you can see if this is a haze image, then this dark channel of this image is no longer dark anymore, and instead it looks like almost like a haze density. It will represent some haze density information to you. So we can use this information to remove to calculate the transmission back and remove the haze particle, right? So based on this idea and how to get the dark channel, from the image. So it's also very straightforward, very easy one. So they just using a sequence of minimum filter. They're using the minimum filter between the RGB channel, and the next they're using the minimum filter within the local patch. So we put these two minimum filter together. We have things equation like this. First, we using the haze-free image here, then the J here. Then we calculate the RGB minimum within this image. Then we get this minimum image between the RGB, right? This is the first minimum filter. Then we're using the minimum filter between the within the local page to get the local minima, and we get this minima local minima result, and we say this is a doctrinal of this image. So this is the way how we extract a doctrinal from a given image. So based on this idea, how we calculate, how we estimate the transmission back. We using the haze imaging model here, fermentation model here, so we can see how we just try to put the doctrinal into this equation. So first we normalize this equation by divide by A for each term. Okay, then we calculate doctrinal on both image. The first on the right hand side, we calculate doctrinal on the input image I, and then we calculate doctrinal on the haze-free image J, single radian J. Then this is the equation of what we have right now. But we know if this J is haze-free image, then the doctrinal of this image must be very close to zero, right? Very close to zero, yeah, because it is haze-free. So we can eliminate this term. So let's see what we have. We get the transmission back, right? We can get the transmission back by using this idea. So it's very cool that if we can see that using this idea, how we get the transmission here is almost looks like what we desire for, right? What we're looking for, right? It's almost like, for example, like some object that's close to you is intensity will be high, and some object far away from you, the intensity is very low. So this gives you some relevant idea about the sync depth, and of course the idea about the haze density, right? So almost we can using that to do to get the sync radian back. But if we take a cross to this yellow bounding box, we can see this all the leaf in this tree are like a blurry, and you can see this looks like a block along this leaf, right? You don't see any leaf in this kind of because of the blocking effect, this kind of patch, right? So if we using this kind of idea to restore the image back, so what we will get? We will get this kind of halo effect in the image. Although we can remove most part of the haze fermentation, but still in this kind of object, some object will surrounding by the white light. So this kind of artificial effect, we don't like these things because we want the restore sync radian lose normal and lose the nature. We don't like this kind of effect, a halo effect in our final result. So how to solve this blocking effect from the final sync radian? Usually, we using this kind of transmission, we will try to do the refinement. So this author in this paper suggests that we can using some mating models. For example, like this one called soft mating, they using in the paper. So if we using some this kind of refinement technique to refine, we can see this from the right hand side is almost to the same to the left hand side, right? So the sync depth, the haze density is almost the same. But you can see that the last of the object detail, you can see this leaf very clearly. Than the left one, you don't have any blocking effect in the right hand side, right? Right hand side is this one. So even this kind of idea can work very well, but it's time consuming. So the same author, they try to solve this problem by publish another paper that can solve this problem too. We call the guided filter, published in 2013. So this is also a good idea to solve this problem, but also more and more efficiency than the previous this one. So based on the same idea, we also find this is a very serious problem when you do dehazing. So we also published another even more faster, more high performance way. This kind of refinement filter in 2016 here. So both of these three methods, you can use in these three methods to solve this problem. I think this will also give you very good performance, very good quality. But maybe the method we did in 2016 can give you best performance here. Okay, so if we get the transmission, then what we left, we still don't have an error line, right? So we need to estimate the error line. So usually the author, they suggest you to calculate to get the error line by this two-step processing. The first step, they say you should find the top 10% of brightness pixel from the dark channel. So maybe the top 10% will be in this region. So you should find this, locate this top 10% brightness pixel first. Then next step, you can find the brightest one from this region directly. So you just pick up the highest one from this region directly. It's gonna be looks like this. So why they suggest you, they also suggest you to do two-step processing is because if you try to find the brightness pixel from this original image, it's gonna result in some false alarm because you see from here we have some brightness pixel on this car, this white car. This white car is not. This is not kind of like a haze particle, right? This is car. The color result in by the car, so it's not the color result in by the haze particle. So usually what we're trying to do here is try to get the most strong haze point. So we're using they suggest you to using this kind of two-step way to doing that. And what we have right now, if we have an ANI, we get the ANI by these two-step processing, and we have the dark channel to calculate transmission. Then we have an input image, the input hazy image. Then we can very easily to get the scene radiant back. So this is basic idea how you to remove a haze formatation from single image. So based on this idea, it's very interesting that the other author tried to using another prior to get even more accurate information, accurate transmission estimation. So this paper color attenuation prior, they say maybe we have another observation. If this is far away distance, this means the haze will be even more strong, right? And this density is very strong, and let's see the brightness of this part, the difference between the brightness and the saturation pixel will be very high. And if the haze is not very strong close to you, the object is close to you here, so you will see the difference between the brightness and the saturation become lower. And the object most close to you, almost haze-free, the difference between the brightness and the saturation almost close to zero, right? So maybe we can using this kind of information also to using this information to estimate the depth information, the depth spec. So we can using this information to recover the scene radius. So this is they just make a assumption that maybe the depth will positive correlated with haze density. Then the C here, the haze density C here. So this must positive correlated with what we observe here. The difference between the brightness and the saturation will be positively correlated with this difference also. So based on this idea, they just say maybe we can using some very simple, very easy, straightforward linear model to model this kind of idea and get the syntax back. So they just using a linear model to build this put the brightness and saturation here to get the best coefficient. They have the coefficient what they have they unknown. This kind of unknown coefficient called theta 0, theta 1, theta 2. These are unknown coefficient in this model, and of course they need some epsilon kind of like a arrow turn in this model. So the way they solving this model is they using kind of like a way like they need the supervised learning method, right? So right now what they need is a supervised learning method, and in this paper they just simply using the gradient descent algorithm to try to get the basic coefficient of this unknown coefficient back to determine this coefficient. So this idea is very cool because back to that time, we don't have much idea because we only consider a single image, right? So we don't have much idea to try to using some supervised method. And as long as you want to using supervised method to learn some unknown coefficient, you need a data correction, right? You need a bunch of data to train this model. So back to that time, it's not easy. It's so hard to correct the data from the in this research community because it's not easy to take a picture. You see if you go to outside and this is in a haze weather condition, you take the haze photo here, but what you're looking for is a corresponding haze-free image. You also need another corresponding haze-free image, right? So it's not easy to capture this haze-free image and the haze image at the same time, at the same point, at the same second, right? It's not easy to do that. So it's almost impossible to do that. So in that time, in 2015, they trying to synthesize the haze image by this kind of random depth map. They just try to add the random depth map into this image and try to synthesize some fake hazy image back to train this model. So basically, this is not a very good idea, really not good quality to train the model because this image is not really close to a real hazy image. But at least this is give us very good start. Maybe we can try to correct the data and we can synthesize some hazy image. And so by doing so, maybe we can using some data-driven method. So this idea is very cool, and indeed we noticed that maybe can we using the power of the deep learning, power of the CNN model to develop some discriminative models to learn from the image pair to dehazing, to do the image dehazing. So can we do that and get an even better high quality synthesized image? So fortunately, from the other community, research community, they're trying to synthesize the syntax, and they get a lot of the ground truth syntax by using the Microsoft Keynote, this kind of device, to get a very nice, very concrete syntax here. So we can using this information to using this model, because right now what we have is J, right? We have a sync gradient here, and we have a transmission. Using this syntax, we have a transmission, and we can get the ANI very easily using the two-step processing. So we can transfer this, we can synthesize this I back. So we can have this data set and the large scale, and we can produce this in large scale data set. And if we have large scale data set, maybe we can try to do some data-driven approach, right? So in 2016, one paper published very early, very first trainable end-to-end system called the HazeNet. They trying to using almost the same idea. They trying to using the haze image to predict transmission here. So this is just a sequence of convolutional layer and then using, so just lots of convolutional layer with some mass pooling layer together to get the final transmission back. So this is nothing fancy here, but they're using just one point, just one thing, cool thing here. They're using bilateral rerule here. So what is bilateral rerule here? Bilateral rerule here is idea is also very simple, very straightforward. They trying to, because the transmission, they trying to give the upper bound and lower bound between within the output value, because they don't want the output value over than 1 or lower than 0. So they just say if the output value higher than T max, then equal 1, and lower than T minute, then equal 0. So they using this way compared to the traditional rerule, the B rerule can give more easy to help this model to converge. So this paper is nothing fancy. They just using bunch of convolution layer and the B rerule with the B rerule activation function together. Is nothing fancy, but just give a very cool idea that we can do that. We can do end-to-end learning. And based on this idea, we see in 2019, my student and I, we trying to do another research. We think maybe this kind of we invent some kind of a predict and refine idea of predict and refine network. Try to avoiding asymmetric transmission. We don't asymmetric transmission anymore. Maybe because of the power of the deep learning model, maybe we don't even need to asymmetric transmission. Can we do that? So we just try to invent this kind of idea. So how we deal with that? We totally just get rid of the transmission assumption. How we do that? We just right now here we notice very interesting question. Is usually if the images is if we have a hazy image and compared to the ground truth, the corresponding ground truth, you see this is kind of like a color case problem, right? If this is color, it's kind of like just color shifting to the white color. So it's kind of just like a color case problem. So maybe can we using the color case the idea, color transfer idea to resolve this problem? So we just transfer this dehazing image dehazing problem to the color case problem. So we're trying to using some kind of the color case technique to resolve this to transfer the color back to the normal one. So can we do that? Actually, yes, we can almost do that because almost remove the haze, right? Compared to the haze image, you almost remove, but you can see still some part is not so good. It's not close to ground truth, but we almost do that. We can almost do to get the sync gradient back, right? So based on this observation, we just using another linear model, and here we have an unknown coefficient theta here, and another coefficient epsilon means the error of the model. And what we're trying to do, I just want to emphasize this kind of interesting things. What I'm trying to do here is directly output the dehaze image, directly output the sync gradient. We don't need to calculate the transmission here, because in this equation we don't have any transmission, right? So here we totally just get rid of this previous haze formutation model. Here we don't need using this model anymore, and because we get rid of this model, we don't need sync depth anymore, right? Because sync depth is always not easy to obtain correctly, right, or accurately. It's not easy to get. Right, so why we need even need the transmission? So we just get rid of that. So this is entire brand new model here, And how to get this coefficient, this unknown coefficient from this model? So basically, we're using the color transfer idea. So only thing we need to do is estimate the standard deviation from the J and I, and the mean value from the J and I. But what we don't have is a standard deviation from the J, because we don't have sin gradient yet, right? And we don't have a mean value from the sin gradient J, right? So how we deal with that? We're just using discriminative model, this kind of power learning technique, to determine the mean value Jn and the standard deviation Js, right? We're just using the first model, the first part of the model, to estimate these two individual value back to finally get the sin gradient back. We can using that just get a sin gradient back. We don't even estimate transmission. So this is a very cool idea. So after we're using that, as you can see, we have a Hasse image input to the first model, and we get the standard deviation and the mean value, and we can recover this image back. But all is the same to the previous one. Is almost there. It's almost remove entire lots of the Hasse formatation, right? Hasse particle. But from the far away from this red bounding box, you can see compared to the ground truth, we still have a little tiny Hasse particle inside the image. How maybe we can do even better to refine this kind of this part. So we're using the second part of this model. This second part model is kind of end-to-end. We just put entire image into this model and try to get the final refinement Hasse-free image out. So compared to the first image from the first model, cross Hasse-free image here, you see the red bounding box. You see lots of the Hasse formation have been removed out by using the second part of this model, right? So this kind of give us quite good performance here. So we're just using another refinement model on the second stage. So put together, we have a very cool idea, and also we have some cool funding here. Because we get rid of this traditional image formatation model, right? So we don't even need to estimate the transmission here. So this gives us very good advantage. We not only our method can not only can do the daytime dehazing, we can also do the nighttime dehazing, because we don't need to estimate the transmission. Because if you need to estimate transmission from the Hasse image, this means the daytime Hasse image is totally different from the nighttime image. Because nighttime image originally is dark, so it's not easy to estimate transmission from this kind of image. It's totally different condition. So you need a brand new model, brand new data to estimate this kind of transmission. So it's not easy to do that. But if we consider this is just a kind of a color case problem, then we can very easily to transfer this image back to the normal one. So this is some side effect, but just good side effect. We can even do the nighttime dehazing. So it's very cool funding by using this model, get rid of the original one. Yeah. So let's just give you some summary about this kind of method right now. Single image approach, they usually trying to using some prior, as I mentioned before, try to estimate some transmission here, some kind of intermediate here, then using the Hasse formatation model to recover the image back. Okay, this is a very traditional way to do that. And sadly, for the data-driven method, for the DeHaze-net, they almost using the same idea, just replace the prior with CNN, with some CNN, but almost doing the same thing, just estimate the transmission, then put it back to the image model, then get the sin gradient, say here. But our idea in this paper, we don't even need to estimate transmission. So we don't estimate transmission. We're just using the power of the CNN to estimate some coefficient, and we can calculate coefficient to this our model, our image model, then get the recover image back, the back. Okay, so this is brand new idea and very cool things to do. So if you're interested in this paper, you can just find this paper online, and the code are also open source. Okay, so what we can do is what we also can do is kind of using this kind of CNN model here. Try to using we put the haze image into a CNN model and get rid of a whole image model. We don't using image model anymore. We're just using the combine all of them together to the CNN model to run say back simulated back. But somehow this is not easy to do in practice, because this is very strong strong assumption that assume that every scenario are share the same features, same contents together, so you can using one model to model all the idea, model all the features. So it's not easy to do this one-step measure. It's not easy to do that. But indeed, in 2020 and 2019 and 2020, still lots of the idea to try to do that. Right now, that because of the power of CNN, even more power than before, then some people, some researchers trying to do this kind of way to remove haze. And indeed, there is some performance here. We can do that, but look, I think the problem, if you do that, maybe you need very deeper model, and it's gonna be very time consuming. So again, but here I just want to mention in image de-hazing, to improve the recognition of the computer vision application from hazy weather condition. That is the question. So usually, what we're trying to do is in image de-hazing is trying to fix the trying to help improve the computer vision application. We don't, because we don't want lots of the false alarm from this application, because hazy weather condition. So this is the real question. Why? Because somehow for the human, they like to have some kind of photography in this kind of hazy or fog condition, right? It's kind of makes people feel good. Even somehow people like this kind of condition. So somehow for people it's not important, but for the machine, for the AI, for some, especially some kind of like a computer vision application, is matter at all. It's actually matter. Okay, so let's just summarize and give you some possible direction maybe for the future you can do. Of course, you can do lots of the data collecting. Of course, even right now, the data set is so important. If you can collect some data set, it's very close to the nature, close to the real one. It's very valuable still, even in 2020. So right now, what you can do, of course, you can still do some deep learning things. You can do lots of the deep learning idea into de-hazing community. Still can maybe bring some even better performance. But maybe we can start by looking for some other solution, for example, like unsupervised way, and some way between supervised and unsupervised called semi-supervised. So maybe this is a good way, also a good way to start with. And other things like reinforcement learning, this kind of idea still very possible to solve the de-hazing problem also. And maybe we can also think about beyond the vision. Why the beyond vision? Because we can this kind of idea we do deep learning things we do right now is kind of post-processing. And maybe we can tool to the pre-processing. We can build this kind of idea into the camera sensor in the image pipeline, maybe into the camera sensor, we can solve this kind of haze formattation. We can remove the haze quickly and more powerfully, more efficiently, right? So maybe think beyond vision. Okay, so other things like there are many application scenario you can use. For example, like driving or satellite imaging or like robot vision or some surveillance system. It's also very possible to do that because for example, like in this one, you cannot do the surveillance system in this kind of condition, hazy condition, right? So in each condition, each scenario still have lots of different problems need to solve. So still very valuable if you try to solving some particular scenario, try to solving a image dehazing in some particular scenario, still very valuable in here. So that's all for today. Thank you for your attention. So I think everyone are tired. So maybe right now I can answer any question you might have. But before that, let me just do another advertisement a little bit. Just do another advertisement a little bit here. What we right now, I'm currently hosting a special issue in the Journal of Mathematical. So it's an open access journal, and welcome everyone to submit to make some contribution in this journal. And I think the data is right now is November 30th. But maybe I think we will. It's very high possible. I will try to extend the deadline. So don't worry the deadline. So just if you have some contribution, welcome to submit to this journal. That's all for today. I can answer any question if you have.
Is there any question? Okay. I think there is no question.
All right.
Thank you, Professor Boho, for giving great knowledge about image dehazing, progress and challenges. Thank you once again to attend this conference.
Thank you. Thank you, everyone.
Now, heading towards closing ceremony, I would like to invite Dr. Deepak Gupta, sir, for giving vote of thanks.
Audible?
Yes, sir.
Okay, thank you. Thank you for inviting me for the closing ceremony of this wonderful conference, where over 120 papers out of 125 accepted papers has been presented in a disciplined manner. Due to unexpected COVID-19 epidemic, the conference has been organized virtually, and all the sessions, keynotes has been conducted smoothly. I would take this opportunity to thank the organizing institutes, Suleyman Demirel University from Turkey, Isparta Applied Science University from Turkey, and College of Engineering, Roorkee, India. The management, faculties, and other members of these institutes are very helpful to make this conference possible. This is the first Indo-Turkey conference, and I hope
I think sir have some network issue.
Hello. I think the connection has been lost of Dr. Deepak Gupta. So on his behalf, I would like to thank the university from,
Hello,
I think
Deepak?
Dr. Deepak is with us. Yes, please, Deepak sir, please continue. Thank you so much.
I think my net is got disconnected.
Yes. You sir. Thank
okay.
you.
Thank you for inviting me for the closing ceremony for this wonderful conference, where over 120 papers out of 125 accepted papers has been presented in a disciplined manner. Due to unexpected COVID-19 epidemic, the conference has been organized virtually, and all the sessions, keynotes has been conducted smoothly. I would take this opportunity to thank the organizing institutes, Suleyman Demirel University from Turkey, Sparta Applied Science University from Turkey, and College of Engineering, Roorkee, India. The management, faculties, and other members of these institutes are very helpful to make this conference possible. This is the first Indo-Turkey conference, and I hope this collaboration will continue for more years to come. I hope the next version of this conference will be physical. Now, I would like to thank our keynote speaker, Dr. Utku Ghosh, my friend, who is always available for us whenever we require his help for this conference, and Professor Chen from Taiwan for the wonderful keynote speeches. Now, I would like to thank our panelists, session chair, session organizers, paper presenters, participants, and volunteers of this conference. At last, I thank our sponsors, supporters, publication partners for the support in the organization of this conference. Now, I announce the closing of this first international conference on computational research and data analytics 2020. Thank you for being the part of this successful conference, and happy Dashera to all. Dashera is an Indian festival which is celebrated in the month of October, and it is a representation of good over evil. So thank you all for being a part of this conference. Now over to Apurva.
Thank you, Deepak sir. Thank you everyone for attending inauguration ceremony and listening keynote talks on emerging technologies. Now I would like to thank the organizing committee for organizing this very successful conference. Have a good day, stay home, stay safe. Thank you very much.
Thank you all once again, and thank you, Dr. Ghosh, Dr. Chen, for giving the keynotes.
I congratulate Aditya Khamparia and his team from LPU. Thank you very much. And thank you, Apurva, for hosting the session very nicely. Thank you very much.
Thanks to all the volunteers, all the students who are working to make this conference possible since the last 10 to 15 days. So the big hats off to you all.
In the last, thanks to all the participants, authors. Thank you very much for joining us. And this is the first Indo-Turkey conference, and I hope this will be repeated next year also. Thank you very much.
Now I think we can end the meeting. Sehajbir Singh, we can end the meeting now.
All right, sir. Going ahead, ending the meeting.
Okay.